Hello students and viewers, this is your data from MOROGORO, Tanzania. My name is teacher Ramadhani Jafari Kidegesho, teaching chemistry. Today I'm going to teach the topic which is called the organic chemistry. This is one of the Form 4 topics, and this topic includes the following subtopics. The first subtopic is Introduction to Organic Chemistry. The second is Hydrocarbons. The third one is Properties of Hydrocarbons. The fourth one is Alcohols. And the last is carboxylic acid. Now, let us start by discussing Introduction to Organic Chemistry. Now, students, what is organic chemistry? Can you define organic chemistry? Good. By definition, you can say organic chemistry is the branch of chemistry that involves the study of preparation, structure, properties, and chemical reaction of organic compound. Now, what is organic compound? Student, can you define organic compound? Okay, organic compound by definition you can say are compounds of carbon with the exception of few, such as carbonate, which contain carbon but it is not organic compound, hydrogen carbonate or bicarbonate, which also contain carbon but it is not organic compound, carbide, which contain carbon but it is not organic compound. So the organic compound are compound of carbon with the exception of few. Now, the organic compound are mainly made up of carbon and hydrogen. So the elements which make up organic compounds are carbon and hydrogen. So these are main elements. Although other elements can appear in a compound, but these are main elements which make up organic compounds. Now, the compounds are referred to as organic because are found in animal and plant matter of both living and dead. So these compounds are referred to as organic because the origin of this compound is from animals and plants. Now, organic versus inorganic chemistry. Before discussing the difference between organic compound and inorganic compound, now let us explain to you first the inorganic chemistry. What is inorganic chemistry? Students, can you define inorganic chemistry? Good. By definition, you can say inorganic chemistry is the study of properties and behavior of inorganic compound. It's the study of properties and behavior of inorganic compound. This is inorganic chemistry. Now, what is inorganic compound, students? Okay. Inorganic compound can be defined as the compounds that contain few carbon atoms or not at all. I mean, there are few which contain few carbon atoms, while there are others which do not contain carbon atom. Now, these are inorganic compounds. Example of inorganic compound including the following: water. The water does not contain carbon atom. Salt like sodium carbonate. Sodium carbonate contains only one carbon atom, but it is inorganic compound. Another example is calcium sulfate. This does not contain carbon atom, it is inorganic compound. Another is potassium chloride. Also, this does not contain carbon atom. Another is magnesium bicarbonate. This contains carbon atom, but it is what? It is inorganic compound. Also acid like sulfuric acid, which do not contain carbon atom. Another is the hydrochloric acid, which do not contain carbon atom. And we have carbonic acid, which contain carbon atom, but it is an inorganic compound. So these are few examples of inorganic compounds. Now, let us look at the differences between organic compounds and inorganic compounds. First, organic compounds are characterized by the presence of carbon atoms in them. As I said, that the carbon is the backbone of organic compound. The absence of carbon, the compound cannot be considered as organic compound. So the organic compound is characterized by the presence of carbon atom in them. But most of inorganic compounds do not have carbon atoms. Some exception exists. For example, maybe sodium carbonate. The carbonate contains one carbon atom. Bicarbonate contains one carbon atom. Carbide, which contains carbon atom. Now there are a few which contain carbon atom, but they are inorganic. But most of inorganic compounds do not have carbon atoms. This is first. Second, organic compounds are highly inflammable. They can catch fire easily. For example, petrol, diesel, kerosene. These are examples of organic compounds. So these can catch fire easily. So they are highly inflammable. But inorganic compounds are not inflammable. They cannot catch fire easily. For example, sodium chloride, hydrochloric acid, sulfuric acid are inorganic compounds, so these cannot catch fire easily. Another difference between organic compound and inorganic compound, the organic compound are said to be more volatile. When I'm talking about the volatile, I mean that those compounds which have high vapor pressure at the ordinary temperature. They have high vapor pressure at the ordinary temperature. They can evaporate easily at ordinary temperature. So for example, spirit. If you leave spirit barely, can evaporate. If you leave petrol barely, it can evaporate at the ordinary temperature, at the normal temperature, can evaporate. But inorganic compound are non-volatile, cannot evaporate easily. Their vapor pressure is low. Vapor pressure is low at the ordinary temperature, so they cannot evaporate easily. Another difference is this. Organic compounds are insoluble in water, but soluble in organic solvent. Insoluble in water means they do not dissolve in water. They cannot dissolve in water. But they can dissolve in organic solvent. But the inorganic compounds are soluble in water and insoluble in organic solvent. They can dissolve in water, but they cannot dissolve in organic solvent. Another difference is this. Most of aqueous solution of organic compound are poor conductor of heat and electricity. They do not allow heat and electricity to pass through. But the aqueous solution of inorganic compound are good conductor of heat and electricity. And in electrolysis, these are used in electrolysis process because they allow electricity to pass through, most of them. So these are differences between organic compound and inorganic compound. Now, after discussing the difference between organic compound and the inorganic compound, now let us discuss the importance of organic chemistry in life. First, Organic compounds are used in making medicines for treating various illnesses. Most of the patients, or the patients in the hospitals are using medicines. So these medicines are made up of organic compounds. For example, aspirin, Panadol, Cipro, all medicines are made up of organic compounds. So they are used in making, organic compounds are used in making medicines for treating various illnesses. Not only that, but also clothes are made up of organic compound called fibers. And these fibers, some of them are natural while others are synthetic. Example of natural fibers are wool, cotton, and silk. While example of synthetic fiber is nylon. So the clothes are made up of wool, cotton, silk, and nylon. For that case, organic chemistry also is used for making clothes. Another importance, fuels such as coal, petrol, and natural gas provide energy for use in industries and homes. Coal, petroleum, and natural gas, these are organic compounds. So these provide energy which we use at home for cooking. For example, natural gases, petrol, diesel, which are used for, others are used for running the car engine and others. So they provide energy which are used in industries, not only industries, but also is used at home. Another importance, synthetic organic compounds are used to manufacture various items like containers, building materials, glass, motor vehicle parts, etc. A lot of items are made by synthetic organic compounds. Now, after explaining to you the importance of organic chemistry, now let us go to another part, which is called the origin or sources of organic compound. The organic compound are derived from three major sources. Which are those students? Can you mention the sources in which organic compounds are derived from? Okay. The sources in which the organic compounds are derived include the following. The first one is coal, natural gas, and petroleum. The second one is living organisms, and the third one is synthesis. Now I will explain one after another, starting with coal, natural gas, and petroleum. Coal. By definition, you can say coal is a combustible black or brownish sedimentary rock formed by accumulation of dead plants matter in swampy areas in millions of years. So these dead plants which accumulated million years ago in swampy areas, or the areas in which the water is collected, form the combustible black materials which are called coal. Now, the process of coal formation. The process starts with death and accumulation of plants matter in swampy areas. So we start with the death of accumulation and the accumulation of plant matter in swampy areas. And the second, formation of layer of dead plant materials mixed with soil and water. Then we end with heat and pressure from top turn the underlying layer into coal. So these are processes in which coal are formed. Processes in which coal are formed. Now after that, the second is petroleum and natural gas. So these are formed from the tiny marine organisms, plant and animals, that died and sank at the bottom of sea millions of years ago. So thin marine organisms, including plants and animals, which died and sank at the bottom of sea millions of years ago, they form petroleum and natural gas. Petroleum and natural gas. The pressure and the heat exerted by the sediment caused the organic matter to change into liquid, which is a petroleum, and gas, which is a natural gas. Now, living organism at the second source of organic compound. Living organisms include plants and animals. Plants can manufacture organic compounds such as starch, carbohydrate from carbon dioxide and water, vitamins, and others. So these are organic compounds which are manufactured by plants. Organic compounds found in animals include glucose, fat, protein, hormones, etc. Now, synthesis. The compound prepared in factories or laboratories through various processes are called synthetic organic compounds. So this synthetic organic compound, these are prepared in industries or in factories or in laboratories through various processes. Example of synthetic organic compound including the following. Polyester is the first one. So this is used for making cloth items. Another is the polyvinyl cyanide. This is used for making clothes, blankets, and the carpets. Another is neoprene. This is substituted natural rubber. Another is the polyvinyl chloride. PVC. This is used for making water pipes, electrical appliances, etc. Another is the polyethylene. This is used for making packaging materials, baskets, cups, bowl, etc. So these are some examples. Now here we have ester. Not only ester, we have polyvinyl cyanide. Another is polyvinyl chloride. Another here is the polyethylene and neoprene. So these are some examples of synthetic organic compound. Now, after discussing this, let us discuss another party, which is called fractional distillation of crude oil. Fractional distillation of crude oil. Crude oil what is crude oil? By definition, you can say crude oil is a naturally occurring and refined petroleum product composed of hydrocarbon deposits and other organic materials. By definition, you can say crude oil is a naturally occurring and refined petroleum product composed of hydrocarbon deposits and other organic materials. This is a crude oil. In another name, you can call it petroleum. The major components of crude oil are residue. The major components including residue is coke, tar, waxes, and asphalt. These are residues. Lubricating oil, fuel oil, diesel, kerosene, petrol, naphtha, and petroleum gas. So these are major components. Remember, residue, petroleum, lubricating oil, fuel oil, diesel, kerosene, petrol, naphtha, and petroleum gas. So these are major components of crude oil. These components of crude oil are called fractions. So these components which I mentioned here are called fractions, which have different boiling points. Each has its boiling point. So the fractions are including residue, lubricating oil, fuel oil, diesel, kerosene, petrol, naphtha, and petroleum gas. These are fractions of crude oil. Fractions of crude oil, and each has its boiling point. Has its boiling point. So in a refinery, crude oil is separated by fractional distillation into different fractions depending on their boiling point. So in a refinery, we use a refinery to separate, and the process is called fractional distillation of crude oil. So in a refinery, crude oil is separated by fractional distillation. By fractional distillation into different fractions. I mean, from the crude oil, in order to obtain, petrol, diesel, fuel oil, residue, naphtha, and others, we use a refinery, and the process is called fractional distillation. The process which we use to separate these fractions is called the fractional distillation. Fractional distillation, and this are separated depending on their boiling point. So the separation is done by heating the crude mixture to about 400 degrees centigrade. So we heat, first of all, we separate it. Before separating, we heat that mixture to about 400 degrees centigrade by passing the resulting vapor up the fractionating tower known as fractionating distillation column, which is this one here in the diagram. So this is the fractionating distillation column. So the crude oil is heated to temperature above 300 degrees centigrade. I mean the temperature of 400 degrees centigrade. After being heated, this temperature is fed into the fractionating distillation column. Fractionating distillation column, which is this one here. Then the mixture will be separated. So the separation is done by heating the crude mixture to about 400 degrees centigrade by passing the resulting vapor up to fractionating tower, which is known as a fractionating distillation column. After that, the fractionating tower is fitted with a series of bubble cap through which the vapor passes and cool as it rises up. As I said, that they have different boiling points. So as they rise up, I mean they cool and change to liquid. They cool, the vapor cool and it change to liquid. So here we feed the crude oil, which had the temperature of 400 degrees centigrade. But that crude oil, some are vapor while the others are in liquid. Those liquid, we call it residue. So the residue use this way to move outside. Then, depending on the temperature, I mean those fractions are cool down and they change to liquid. So once they change to liquid, they move out according to the temperature they have. Now, the different fractions are cooled and condensed at different temperature and collected. So the heavy fractions are collected at the bottom of the fractionating tower, and the light fractions are collected at the top of the fractionating tower. So those heavy fractions, from those which do not change to vapor, we start with those which do not change to vapor, we call it a residue, which including coke, tar, asphalt. All these are collected at the bottom of the tower because they do not change to vapor. But as you rise up, the temperature decrease. As you rise up, the temperature decrease. As you see here in this tower here. So the bitumen, this one is one of the residue. So the residue will be collected through this pipe, and those which can be cooled at the temperature of 350 degrees centigrade, for example, fuel oil will be collected, will be cooled in this area here, and be collected in this pipe, which is fuel oil. Another which is cooled at the temperature of 250 will be collected through this pipe here. This including diesel, oil, kerosene. Others which has a temperature of 120, which is a naphtha, will be cooled and collected in this area here. And those which cooled at the temperature of 50 degrees centigrade, including gasoline or petrol, will be collected in this pipe, through this pipe. But the refinery gas will move out through this pipe here. Now, so the heavy are those which are collected at the bottom, but the light one, or the light fractions, are collected at the top of the fractions. Now consider this diagram here. This diagram here, this is a bitumen. Bitumen is one of the, first of all, the crude oil is fed through this pipe, where there is a heater here. The heater heats the crude oil to the temperature of 400 degrees centigrade. So once the crude oil is fed into the fractionating distillation column, those which do not change to vapor will be collected in this bottom pipe, which are bitumen and the other residue. While those, we have a lubricating oil here, we have a fuel also. As you raise up, the temperature decreases. So the diesel here can cool at the temperature of 260 degrees centigrade. So they are collected in this pipe here. Not only this, but also kerosene cools at the temperature of about 108. So it will be collected through this pipe. Another is naphtha, which cooled at the temperature of 110 degrees centigrade. So it will be collected through this pipe. Petroleum, which is cooled at the temperature of about 30 degrees centigrade, will be collected through this pipe. So the refinery gas, or we call it petroleum gas, will move out through this pipe. And this one here are their uses. The fuel oil is used in ship, fuel for ship, factories, and the central heating. Lubricating is used for lubricating different things. Not only that, but also diesel fuel is used in cars. Not only that, but also kerosene. This one is used as a jet as a jet fuel. Also, we have a petrol here, which are used in cars, petrols for cars, for vehicles. Not only that, but also refinery gas, or in another name we call it petroleum gas, are used at home for cooking. So these are uses of different crude oil fractions. Crude oil fractions. After discussing that, now let us look at the uses of crude oil fractions. Now, starting with the petrol. Fraction uses. Petrol, it is used for internal combustion of engine, as we have seen there, internal combustion of engine of cars. Also, it is used to manufacture the petrochemical. There is a petrochemical which is manufactured by petrol. Another is naphtha. This is used for making petrochemical and used as motor fuel. Another is paraffin. This is used as a jet fuel. Paraffin is a kerosene. So as a jet fuel, it is used for domestic heating. It is used, it can be cracked to produce petrol. So this one can be cracked to produce petrol. Another is diesel. So this diesel is used in fuel, as a fuel in diesel engine. Also is used for industrial heating. Also can be cracked to produce petrol. Another is lubricating oil. This is used as grease and other lubricants. Another is fuel oil used for industrial fuel. And the last one here is petroleum gas, which is used for heating and cooking. Also, it is used for making plastic. So, these are uses of different fractions of crude oil.
In our other videos, we have learnt how fractional distillation is used to separate hydrocarbons into fractions with a similar boiling point. In this video, you will learn the names of some of the most important fractions and their uses. As you are now aware, large hydrocarbons have higher boiling points and so are removed at the bottom of the fractionating column. Smaller molecules condense higher up the column. We will now take a look at some of the common fractions as we move down from the top of the fractionating column. Some of the smallest molecules are between 1 and 4 carbons in length. This fraction has such a low boiling point that it is still a gas when it is removed from the very top of the fractionating column. This fraction is known as refinery gas or bottled gas. Bottled gas because it can be stored in bottles under high pressure. You could well have seen bottles of propane or butane running barbecues or heaters in your home, and these are examples of the refinery gas fraction. Petrol is between 5 to 7 carbons in length. It is still a fraction of small chain hydrocarbons, and therefore these vaporize at a low temperature and are easily ignited. This makes it useful as a fuel in the internal combustion engine of a car or other vehicles. Naphtha is not such a useful fuel, but it is a valuable source of organic molecules which can be cracked to make more fuels or form alkenes. Alkenes can be turned into polymers, and polymers can make plastics which are used in our everyday lives. Kerosene has an important use as a fuel for jet engines, in aircraft and even in some rockets. Kerosene is also called paraffin in some parts of the world and is a common fuel burnt in paraffin or kerosene lamps used for lighting. Diesel is the next fraction. It is a common fuel in cars, vans and lorries. It is not as volatile as petrol, and instead of spark ignition, it ignites under compression. Below diesel are the residue fractions. Fuel oil is a fuel used in power stations and ships. Lubricating oil, which sticks to surfaces and reduces friction and protects from rust. And finally, waxes, which along with the oils can be used for polishing surfaces. The very bottom fraction is bitumen. This is a thick black adhesive used on roads, either as the surface finish or combined with stone chippings to create a solid, resistant material. It can also be used to cover roofs due to its waterproofing properties. All these fractions are separated from the crude oil mixture. To try and explain the importance of crude oil, consider these facts. There are estimated to be over 1 billion cars in the world, of which many will be using petroleum as their fuel. There are many million flights each year, each burning kerosene fuel. Not forgetting the massive plastic that is made and used each day for products and their packaging. Even the bitumen used to surface and resurface roads around the world. As you can see, crude oil contains many useful products that just need to be separated from the crude oil mixture. Now, at the end of this lesson, you should have a better understanding of why crude oil is such a valuable resource and the use of each of the main fractions.
Now, this point here marks the end of my presentation You were with me, teacher Ramadan Kidegesho. Thank you very much for listening. Thank you very much for watching this video. Goodbye.
NLab Innovation Academy inatangaza nafasi za masomo ya Information Technology kwa ngazi ya certificate na diploma kwa wanafunzi waliomaliza kidato cha 4, kidato cha 6 na chuo NTA Level 3. Chuo kipo Kinondoni Vijana jijini Dar es Salaam. Zaidi ya kusoma, mwanafunzi anapewa nafasi ya kuanzisha mradi wa kiteknolojia pamoja na kupatiwa mentor wa kumwongoza. Pia tunamsaidia mwanafunzi kutafuta scholarships pale anapohitimu. Tupigie leo 0677 071 486 au 0744100231 au tembelea tovuti yetu www.nia.ac.tz.